Okay, today we're talking about linear inequalities. Linear inequalities sound a lot like linear equations. It is a line that we're going to draw, but instead of an equal sign, which is what usually is in equations, we have inequality symbols, which look like those. It is still a line, except this time we have something called a solution set. So it says, how do we graph them? We graph them just like normal lines using our y equals mx plus b or standard form, anything like that. But then we're going to have to find some place to shade. That means that we take a point and we test it and we figure out what the solution set is. That means part of the graph is going to actually be the answer. So I'm going to go down here to the two examples, and I see that these are both technically written in y equals mx plus b. The b is the y-intercept, so I'm going to graph this first at 4. And then my slope says -3, so that is down 3 over 1, down 3 over 1, down 3 over 1. The other thing that is really important to know is that this and this are very different from each other. They do different things. This or equals to, anytime you see the or equals to symbol, you draw a regular solid line. If you see a greater than or less than and then no equals to, we're going to actually have to draw a dashed line, because what's going to happen is the answer is technically not exactly that line. Pretty crazy, but that's how it works. So this one is a solid line. I'm going to draw the solid line. I am not done, because that is just a normal line. What I have is a linear inequality, so I'm going to have to figure out if I'm going to shade this part or this part, which means I need to figure out if this half of the graph is the answer or this half of the graph is the answer. So this is how I do it. I test, this is how I know what to shade. I test a coordinate. Usually I test the origin because it is the easiest. So I'm going to take 0, 0 and plug it into my original equation for the x and the y. So that means I have 0 is greater than or less than -3 times 0 plus 4. I know that -3 times 0 is 0 plus 4 is 4. This says 0 is greater than, this one it says 0 is greater than 4, and that is actually not true. 0 is not greater than 4. Because the origin does not work in my original equation, that means the origin is not part of my answer. So since this point is not part of my answer, all of these points would have not fit into my equation, which means that this side does. Let's pick a point over here, like 2, 2. I'm going to show you that it will work in my equation. So I'm going to take the original y, -3x plus 4, and change them for 2's. So I have 2 greater than or equal to -3 times 2 plus 4. I know that -3 times 2 is -6. And -6 plus 4 is -2. So that says -2 is greater than or equal to -2. And that is a correct statement, which means that this point worked. It didn't matter which coordinate we would have chose over here, it would have worked. So let's try this one. I'm going to go a little bit quicker. -5 is the y-intercept, and my slope is up 3 over 2. Up 3 over 2, up 3 over 2. Now remember, I said that this was a dashed line because of the inequality symbol. It is not exactly equal to. And I always put my arrows at the end of my line to show that it is going on forever and ever. Now I have to figure out where to shade. So the easiest point I could use is the 0, 0, the origin. So I'm going to replace the original equation with zeros in for the x and zeros in for the y. 0 times anything is 0, and 0 minus 5 is actually -5. So I have 0 is greater than -5, which is true. Since it is true, I am going to shade in the part that it's true. The back has examples of standard form, where ax plus by equals c. Oh, darn it. The second half of this video will come later.